Good. So some of these questions we already have covered. So just a refresher. So question number 1 says, briefly but clearly explain the purpose of input-output analysis. So you can write that. The purpose of input-output analysis. Write that this is the study. This is the study of the interdependence between various sectors in an economy. Interdependence between various sectors in an economy. The interdependence is in terms of sources and quantities of inputs. Sources and quantities of inputs to a sector. And uses and quantities of output from a sector. Yeah, so basically we know that's the purpose of input-output analysis. So part B says, consider a hypothetical economy consisting of 3 sectors, A, B, and C, with inputs and outputs from a particular period. The balanced transaction table has the form shown in the following table. The figures given are billions of shares. So we are given that. Now you are told, number 1, to form technical coefficients input-output matrix from the above data, and we call it matrix A. So technical coefficients matrix. Now this matrix we said is normally called matrix A. And on this side, we have the producer. And then we have the sectors. We have sector A, sector B, and sector C. Then we have sector A here, sector B, and sector C. That is the user and the design. So we said what you do, you take the units that are given there. Like for A, we have 18. You divide by the total of that row. The total is 108. And remember we said the values in a column are divided using the total in that row. So if you're in column 1, you divide using the total of row 1. So then this one will be 27, divide by 108, and this will be 54, divide by 108. This is 30. You divide by 120. 30, you divide by 120. 40, you divide by 120. Then we have 45, you divide by 180. We have 60, you divide by 180. 60, you divide by 180. So take the calc and give me the answers. Kwanza, 18 divided by 108. 0.167. Or it's not exact. Then we can confine ourselves to 3 decimals. You give it 27 divided by 108. 0.25. Then he give it 0.50. 30 divided by 120. 0.25. The same case here, 0.25. Now we begin 0.33. Tuende kwa yule mwingine 45 out of 180. 0.25. 0.33. The same, 0.33. So that is the technical coefficients matrix. Technical coefficients matrix. Part B, we are told if the external demand, remember external is the one we call final. If the external demand was to change from 15, 3, 26 to 10 to 20, calculate the total output of sectors A, B, and C, and you may assume the universe is like that. Remember, I told you there are 2 ways of getting the total output. There are 2 ways of getting the total output. One is the one we said A plus Y is equals to X. And this is when the values are given in whole numbers, like is the case in the question there. But if you have new values and you have ratios, then we say X is equal to I minus A inverse, you multiply by Y. So we need to get this. It is 1 out of 109. 1 out of 109. We multiply by 336, 288, 396. So 216, 372, 348, 234, 294, 486. Times the new matrix Y. The new matrix Y. So the new matrix Y is 10, 2, and 20. So this being our last lesson, I don't expect that you don't know how to multiply matrices. So the calculator is that. So we said you create a 7 when multiplying a matrix. You create a 7. So utasema 336 times 10 plus 216 times 2 plus 234 times 20. You say equals, then divide by 109 and give me the answer. Eh? 0.72. Good. So we begin the next one. The same 288 times 10 plus 372 times 2 plus 294 times 20. Same equals, then divide by 109. 87.19. Next is 396 times 10 plus 348 times 2 plus 486 times 20. Divide by 109. 131.89. So those are the outputs of those sectors. That is sector A, sector B, and sector C. So the question is asking, what is the intermediate demand in this case? So we are told to get the intermediate demand. Intermediate demand. Now this one, we are going to use the formula that, remember, intermediate demand is always matrix A. Eh? It's always matrix A. Maybe I'll need to say that intermediate demand plus final or the external demand is the total output. Remember, this is the one we are saying this is A plus Y is going to give us what? X. And thus, if I'm looking for A, it then must be X minus what? Y. So I will have the sector here and then intermediate demand. Intermediate demand so sector A, the final output is 77.72. The intermediate demand is, rather the final demand is 10. So that would give us 67.72. Sector B, the final demand is, or rather the final output is 87.19. So you minus 2, that gives you 85.19. Then sector C is 1.89 minus 20. And that must be 111. So we are through with that. Go to question 2. Question 2. The lifetimes of a certain type of electrical component are distributed with a mean of 800 hours and a standard deviation of 160 hours. So if the manufacturer replaces all the components that failed before the guaranteed minimum lifetime of 600 hours, what percentage of the components have to be replaced? So that question is might be about normal probability distribution, normal probability distribution. So we are told those which are below 600. So below 600 hours. So below 600 hours, you design a table that you know so well, like this. Then here we have the mean, X bar. So we are told that the mean is 800 and the standard deviation is 160. So we want those which are below 600. So that must be our X1 here, which is 600. So if it's 600 that way, then we know that Z1 is X1 minus X bar. You divide by standard deviation. So this will be 600 minus 800. You divide by 160. I'm sure we are fast because I want to solve all the questions within the lesson. In any case, there are things that we know. So just that I might. Negative 1.23. Because values of Z, they are always given to 2 decimals. 25. Oh, 25. Exact. Oh, okay. 25. So from the tables, the probability that X is below 600. This one we know that what we shall read will be the probability from 800 to 600. So to get the lower one, we must then say 0.5 minus. So end up with a table in Somei, 1.25. Go to the normal tables and read. Umepata nini? 0.3944. So when you get the answer, the difference, you read like it is positive. 1056. So the percentage below 600 hours is 10.56%. Then, if the manufacturer wishes to place only 1% of the components that have the shortest time, what value should be used as the guaranteed lifetime? So, the minimum life, we want to replace just 1%. So if that is what we want, this one will be the mean here, which is 800. The standard deviation here, which is 160. Now, for us to replace the ones that not hit the minimum, they must be on the lower side. So we will come here and say that this X1 is the one we do not know, but we are told this one that we want to replace must be just 1%. So if it is 1%, that must be 0.01. And because we know the whole of this region is supposed to be 0.5, then this one we know is 0.40. This should be, no, 49. Should be 49. Should be 49. Now, using this formula that is here, this one, we make X1 the subject, so that we are left with X1 equal to X bar plus Z standard deviation. When we make x1 the subject of the formula. Sasa, x bar we already know is 800. Plus, go to the tables, inside the tables, after 0.49. Go down the tables, look for look for 0.49, where you find it, 2.33, and because these values now it's on the lower side of the mean, it should be negative. So the value Z should be negative 2.33. You multiply by the standard deviation, which is 160. $427.2 hours. So I think that one is okay. So that was just to remind you about the normal distribution. There are still two other distributions that you need to check. There is the one we call Poisson and the one we call binomial. I think in the course of division we have been handling some questions on that. And if you don't remember, I think I've approved some work on the exponential. Exponential, I'm not very keen. I'm not very keen on it. It is rarely examined. They used to be more common in a topic called queuing theory, which is no longer part of your syllabus. So I'm pessimistic. But all the same, because it's introducible, you can check that in your notes. You can check those formulas. But I'm very pessimistic that they can do it. But I'm not saying they can't. They will see it on part It's only that it is used to be in a topic called queuing, and queuing is not even part of the syllabus. So I've said these ones you can check what we have been doing in class, and I have also uploaded, I think, some workings on the same channel. So to end the question 3. Question 3, the following of the monthly electricity bill at Chase Paul restaurant over the past 12 months has been as follows. So Paul is considering using exponential smoothing with 0.5 to forecast future electricity sales. So you are required to forecast that for him. So the question is meant to remind us about the exponential smoothing method. And as you know, we have the period. So in this case, it is the month. have the man here. Then we have the amount. This is our AT. Remember, a month is our T, the time period. The time period. Then we have the forecasts. And the forecast, you should remember, we always use the formula of FT plus alpha A minus FT is equal to FT plus 1. That's how it's done. It's huge. So we start with the first month, December. So December, we have 3660. I told you for the first period, the value becomes the forecast and the actual. The first value. So that would be the forecast here, 3660. Alpha is 0.5. Oh, sorry, I should have said this is 80. This is 80. So the actual is still 3660 minus the forecast 3660. So that the answer will still be 3660. That is what we said about the first period. The first period, the first value becomes the forecast, and it is also the actual. We go to January. Now, January, the actual is 27,190. So when you're in January, the previous period is December. So the forecast for December is 3660 plus 0.5. 0.5. The actual for December is 3660. And the forecast is still 3660. So that the answer still remains 660, 3660. We go to February. February, we have 3570. 3570. So when you're in February, January is the previous period. So the forecast is 3660 plus 0.5. The actual for January was 27,190. The forecast is 3660. So give me that answer. $28,925. $28,925. Confirm, okay? March. March, the actual is 3640. 3640. So 3640, the forecast for last time is 28,925 plus 0.5 plus 0.5. The actual for the last period is 3570 minus 28,925 . 29,747.5. Confirmed? April, the value is 29,730. 29,730. In 29,730, the forecast here is 29,747.5 plus 0.5. Actual for the last period is 3640 minus 29,747.5. One 170.25. 31. Point. Confirmed. Then we go to May. May, the value is that 1,530. That 1,530. So we will take 3193.75 plus 0.5. Actual is 29,730 minus 3193.75. Let's now confine ourselves to decimals if they go beyond that. $29,961.88. Confirmed. Okay. June. The actual is 29,720. So sasa unachukua ile forecast ya 29,961.88 plus 0.5. The actual is that 1,530 minus 29,961.88. $37.94. July 9 hakuna 33,070. So 3745.94 plus 0.5. The actual is 29,720 minus 3745.94. 30,000 to that 2 points. 97. Huyu mwingine ni August. You're getting a different value of the others. Have we confirmed? This one, eh? Okay. So it is 32.97 plus 0.5. The actual is that 3070 minus 32.97. That's 1,051.49. September 27,550. So you take the forecast there, that 1,651.49 plus 0.5. The actual is 30,010 minus the forecast that 1,651.49. 30,830.75. October is giving us 3130. So you take 3830.75 plus 0.5. The actual is 27,550 minus 3830.75. 90.38. So then we go to November. November, we have 27,940. 27,940. So we are going to talk of 29,190.38 minus, not minus, but plus 0.5 into brackets. The actual for the last period is 3130 minus 29,190.38. You get 29,660.19. Now we go to December. Now December is the one whose value is being required to be forecasted. And we said when you are using the exponential smoothing, you predict the next one period. So we don't have the actual, so we take the forecast of 29,660.19 plus 0.5 brackets, the actual 27,940 minus 29,66.19. 28,800. 0.1, eh? So that is the forecast for December if you are using the exponential smoothly. We are using exponential smoothly. If for some reasons they told you to use unweighted moving average, 3 moving average. We are told to use unweighted 3 moving average. The December forecasts, I told you, you simply take the last three. The last three. So the last three are 27, 940, plus 30, 130, plus 27, 550. You add them and divide by 3. You add them and divide by 3. Hmm? 28,540. The next one is if you are told to use weighted 3 moving average. Weighted 3 moving averages. We can rate WIs to be 0.8, 0.15, and 0.05. When you are told rate, that means we are assuming. So with that, the December forecasts. The December forecasts. The December forecasts. I told you the most recent gets the highest weight. So we will say 0.8 times the most recent, which is 27,940. Huyo mwingine 30, so 0.15 times 30, 130. Plus 0.05 times 27,550. $28. The other one, which I don't want to do so that it does not take out of my time, is the regression. you're using regression. The same when you're using regression, these time periods you just number them. They become your x, and these values become your y. And we all know how to develop the equation of y is equals to a plus bx. So you have to know exactly. The next is question number 4. Question number 4 is you're told the purchasing department has analyzed the number of orders placed by each of the 5 departments in the company by type for this financial year as given in the table below. So we are given all that, and then we are told an error has been found in one of these orders. Now determine the probability that the incorrect order was not for consumables. So that question is what we call contingency table in probabilities. Contingency table in probabilities or probability theory. That's where it's coming from. Contingency table. And we know when we are told Roman 1, probability that an incorrect order was not for consumables. That means it was for all the others, but not consumables. So not consumables. So not consumables, probability not consumables. So you go to where you can see consumables. Consumables water in that heat. You see that? The total of consumables is 38. So the ones that are not consumables in 15 and 7. Then you divide by the total. It's as simple as that. .867. Roman 2, determine the probability that the incorrect order came from maintenance or production. So probability that you're from maintenance or production. Maintenance or production. So you bring the total of maintenance. Maintenance has a total of 7. When you see the word all, it means plus. Production is 17. And because they do not intersect, there is nowhere they meet there. There is nowhere they meet, so there is nothing to subtract. So you divide by 60. .4. Probability that the incorrect order was an equipment from parties. So probability it is equipment from parties. Equipment from parties. In other words, this is the one you are saying given. The Bayesian equipment given patches. So we said you got to patches first. You identify patches. Then when you're in patches, you pick equipment. There are how many? 3. And the total patches is what? 15. Zero point. So that is about contingency tables. It's very simple or that way. So the other bit in probabilities that we will not be able to touch is probability trees. Probability trees. I think we have come across a question during blocks, and if not, there is an upload in the channel. I think there are 2 or 3 questions. Please check. Question 5. The table below shows the income per month of borrowers and percentage of all mortgages as provided by Building Society Mortgages in the year 2000. So we have given all that. You are told to calculate some suitable measures of central tendency and dispersion and comment. So that one I just wanted to remind you there is that topic, because during blocks we did not come across a question on that, because these descriptive statistics is a very new area. It's a very new area, and chances are they might slip a small question there. So the data is grouped. So measures of central tendency. Central tendency. So the measure of central tendency, when the data is, or actually we just have one, the most common, that is the arithmetic mean, x bar, which is given as sum of fx. I don't know whether we should have started by preparing the table. I think we should have started by preparing the table so that let's prepare the table first. So the analysis table. So we have income per month. Now that income is the class. So we will need to get what? The midpoint, which will become our X. Then we have the percentages. And these percentages will become our frequency, the frequency. We know for us to get the mean, we will require to get F multiplied by X. To get standard deviation somewhere, we will require F multiplied by X squared. And to get some measures of other things, we may require the cumulative frequency. I think those are the columns that we will require. So we have 0, 30,000, 35,000, 40,000, 45, 50,000, 60,000, 70,000, 100,000, 150,000. So obviously this is going to go to 29,999. Then we have that 4,999. You have 35. It should be 39. 39, there's a typo there. So 3999, you equal 44, 999, ingine equal 49, 999, ingine equal 59, 999, 69, 999, 99. And then 149, 999. Sasa, this one is not given up to where. When you are not told up to where, you will take note from the previous. Now the previous has a gap of 50. Yeah, so this one now should go up to 199, 999. So kama hajakwambia at the end of the last one, you give it the same width as the second last. Haya, midpoint, tunajua we need to add and divide by 2, so we can start giving me. The first one is what? That data will be extra huge. The next, that's 2. 499.5. That's 7. 499.7. I don't know how far you have gone. How far you have gone. Not but this data will be too huge bad. Ndio, the square. The square kama hii. Does it have times? That data will be too huge. Yeah? So we shall modify because hoja yetu si solution, hoja yetu ni procedure. My purpose is not the answer but the procedure. So sasa karabati namna hii. Ndio. My purpose is not the answer but the procedure. Manager. Manager. So make that adjustment so that we don't spend a lot of time to achieve something we could still achieve easier. But now, for exam, you don't go adjusting. The exam, you use the data that is presented. But for me now, I have the freedom because my agenda is not the answer, but the procedure. So with that now, this is 14 points. 5, then that 2 points, or just that 2. Then that 7. Exact. 42, 47, 54.5, 64.5, 84.5, 124.5, 174.5. Haya, sasa tuweke the percentages. We have 5, we have 2, we have 3, 5, 10, 15, 18, 21. And these are the questions that used to be done those days that students will not be allowed to use calculators. That's never on a calculator use. It used to be overhead. The time when I talk about the too sharp in terms of numbers. 14.5 times 5. 72.5. The next 64. 370. Tafika. 111. Then 210. 470. 817 points. 5. Exact. Yes. Because there are 5 there. 105. 17. 1774.5. Iko sawa? Okay. Haya, huyu mwingine? 21.16.5. 698. Give me the total. $74.95. Na hii percentages, were they going to 100? Okay. Let's come here. Fx squared. The first one. I hope you remember what I told you about that. Are we squaring this? Or what is happening? You square x, then you multiply by. In other words, it is this one now, you multiply by this. Yeah, so make sure you always note that, because most people make a mistake here by squaring this. So it is x squared, then you multiply by f all. This fx, you multiply by this x again. So if you do that, 51.25. That's 2 times 64. 2048. That is 7 times 111. 107. 42 times 210. 9820. 8820. 47 times 470. 22. 090. 54.5 times 8, 17.5. 553.75. 64.5 times 11, 61. 84.5 times 17, 74.5. 124.5 times 2116.5. 25. 174.5 times 698. Exactly. Yes. Okay. All right. So give me the total of that. Six 692,805. Exact. Okay. So cumulative, this is 5 plus 2, 7 plus 3, 10 plus 5, 15 plus 10, 25 plus 15, 40, 58, 70, 9, 96 and 100. Yeah? So because my agenda is just to remind you about that topic, I'll just compute one the measures just to give you an idea. So I want to start with the mean x bar. Now x bar, we know it is sum of fx, you divide by sum of f. Now this one is 74.95. You divide by sum of f, which is 100, and that is 74.95. 74.95. That's one of the measures of central tendency. So you can go check how we compute the mode and the median. Haya, tukikuja kwa dispersion, maybe I compute variance. Maybe I compute variance. So variance is given as sum of fx squared. We divide by sum of f minus sum of fx. We divide by sum of f. This all of these is square. All of that is square. So the sum of fx square is 692,805 divided by 100 minus 7495 divided by 100. To square that. Mm-hmm. 1,000. Okay. So that is a measure of dispersion. So you can check others like standard deviation and the coefficient of variation. The standard deviation, the coefficient of variation. In terms of the quartiles, maybe I can compute Q3. Q3. For the quartiles, we said what you do, you take the lower limit, L, plus N, and N is multiplied by the quartile that you are looking for. So we will talk of 3N, and because quartile divides that into 4, you divide by 4, you minus the cumulative frequency of the class above that. You divide by the frequency of the class, then you multiply by W, the width of that class. So we will need first of all to get 3N out of 4 is going to be 3 times 100 out of 4. Hmm? 75. So the class, we need to know which class is that. Which class is that? So nakuja unatafuta 75. 75 lazima ikuwe hapa. So it is the class of 70 to 99. To 99. I told you there are 2 ways of getting the width. If the widths are the same all through, like you can see here, naona hapa ni 5, 5, 5. Lakini tukifika hapa zinaanza kubadilika. Yeah. So if they are not the same, what you do, this one, the upper one, you just add 0.5 so that you see 99.5. And the lower one, you less 0.5 so that you work with 69.5. If they are not the same, you get the difference. It's like the difference with the 2 when you add 1. What is the width? 30. Kama ile mahesabu ya perimeter which we used to do in class 3. Naambiwa kama wants to fence his house. How many poles? Remember? The distance between neighboring poles is 3 meters. Na shamba yake ni this. You used to divide, then you add 1. The same concept. So the width is that, which at times you may see as the difference. Yeah, no, this one. See that? Yeah. But the surest way is that one. But ukiemewa, you can still go by what you are saying or what you are used to. So let's substitute. Substituting L, so the lower limit is 70, or you can use 69.5, whichever you want. 70 plus 75 minus the cumulative frequency above. The cumulative frequency above is 58. The frequency of that class, is 21 times 30. You have 94 points. 94. So with the same understanding, can you be able to get the aggressor on percentage? Yeah. So make sure you compute one decile. Like you can compute decile 10 and maybe percent at 40. So with that, tutakuwa umekumbuka mambo na descriptive statistics. So being a new topic, I'm suspecting they might throw out a small question. But it's a very simple area. Very simple area. Focus on it. Question 6. We are told to define the following terms as used in Markov transition matrix. I think the other day we came across transition matrix and we defined, remember, and we give characters of a transition matrix. The same is a matrix whose elements are probabilities of moving from one state to another state. Initial probability vector, that is the matrix that shows the current state, yeah, or the initial state. In QA, there is no problem repeating or defining a word using the same word. It's not grammar. In grammar, that's why you should be rich in vocabularies. Equilibrium is the point at which the current is the same as the future. There is no change. It is also what we call the long run or the steady state. Absorbing state, to say it is a state where you join, but you cannot exit. So I think those are things you can comfortably define in your notes. Now here we are told a company employs 4 classes of machine operators, A, B, C, D. All new employees are hired. So we are given all that, and we are told to get the transition matrix. So let's design that matrix. Then we read as we answer. Transition matrix. So we have 4 states here. The design. So the question says that a company employs 4 classes of machine operators. All new employees are hired as class D. And through a system of promotion, employees may work up. There's missing word there. Employees may work up to a higher class. Currently, there are 200 class D, 150 class C, 90 class B, and 60 class A employees. The company has signed an agreement with the union specifying that 20% of all the employees in each class be promoted 1 class in each year. So what that means is that if right now you are in a particular class, after 1 year you go to the next class. So we can start from D, the lowest class. So if you are right now in class D, you will go to class C. So we will argue from D to C. 0.2. Wale wametoka kwa D wakaenda C. Unaelewa hiyo concept? Hapo. Wewe ukitoka hapa sec 2 unaenda wapi? Si sec 3. Yes. So mwenye ako D anaenda the next class which is C. So we are arguing from D you go to C. 20%. Umeelewa hiyo? Haya, then sasa tusha promote watu wa D. We now go and promote watu wa C. So it is from C to who? So from C to B. Hapa. Now we go promote who? The B guys. We are promoting them to, so from B to A. Now promotions measure because now A guy you cannot promote him any further. Still, yeah. The A guy cannot be promoted any further. Haya. The next thing tunaambiwa, statistics show that each year 25% of class D employees are separated from the company by reasons such as retirement, resignation, and death. The meaning of that is that at the end of the year, the guys who are currently in D will quit. And we had been told that once someone quits, they are immediately replaced. And they are replaced to come and join D. Anyone joining the company must join D. So what will happen to D? Tutapoteza 25 na turudishe 25. The net change is 0. So hiyo 25 hakuna mahali itaonekana. Kwa sababu imekuja na ikatoka. That's so terrible. Umeamuka na ukakaa. So what is the next? What is the change in the weight of the chair? It is 0. Yes. Similarly, 15% of class C, 10% of B, and 5% of A are also separated. So these guys that we lose from C, we will replace them. But tukiwa replace, wanakuja kuanza kama B. So it is from C to B. So kuja weke hapa. Ni 15%. Then the guys we lose from B, they are 10. So what how it is from B wakuja hapa B. And the guys we lose from A, they are 5%. Nakibia tunaweka hapa. That's all. So whatever is remaining, at least we know that the row must always add to 1. So the row in a transition matrix must always add to 1. Here, this is those who are in A and have remained in A. So hatujui ni wangapi. Hawa ni wale wamekuwa demoted from A to B. But the question has not mentioned of demotions. What is happening is fine. So now that the question has not mentioned to us of demotions, then we can comfortably say this is 0 and this is 0, and therefore the company must have obtained 0.95. Because no one was demoted. Similarly, tukikuja hapa kwa B, hii yenye imebaki hapa, it is those who remained. We don't know how many they are. This one, it is those who are demoted from B to C, but we don't have cases of demotion. So this one becomes 0. And if it becomes 0, it then tells you B must have retained 0.7. B must have retained 0.7. Aya, tukikuja hapa kwa C, hawa ni wale watu walikuwa promoted from C wakakuja to A. And that is not possible because kila mtu anakuwa promoted just one grade. Na tusha promote from C to B to A. So hakuna mtu alitoka kwa C akaruka all the way to A. So hii ni C. Therefore, A must have retained, or C must have, this is 25, eh? So they must have retained 75%. Oh, is that 5? Oh, 65. And then no one was promoted from B akakuja A, ama akakuja B. So B must have retained 0. That is the transition matrix. So the number of employees in each class 2 years after the agreement. So you need to get the current state, the current year, you multiply by the transition matrix, you get next year. So currently, when I taught you back of we used more ratios. But it's not a must that all the time you use ratios. So you can use whole numbers. We are told right now in class A we have 60. B we have 90. C we have 150. And this other one we have what? If you want to use ratios like the way you are doing in class, you now add all this, then each one you divide by the total. Each one you divide by the total, so that the answer utapata huko it will be ratios. But ukitumia the whole numbers the way they are, the answer will still be totals. It is the same thing. Because ukisha work na ratios, you will require to multiply by the total, so that you get the whole numbers. So we are supposed to multiply now by 0.95, 0.200, then 0, 0.7, 0.2, and 0. Then 0, 0, 0.65 and 0.2, then 0.05, 0.1, 0.15, and 0.8. Know how to multiply matrices again. So we create our 7. So give me 60 times 0.95 plus 90 times 0.2. $75. So you just avoid where they are zeros. So you get 90 times 0.7 plus 150 times 0.2. 23, 93. Give me 150 times 0.65 plus 200 times 0.2. 1. 0.5. We can still take human beings as 0.5. Still okay. Then that's how you get a multiply. 60 times 0.5, 0.05, 90 times 0.1, that's 150 times 0.15. $194.5. And what you should notice is that the total here, this one, is the same as this one. Confirm that that's the case. The total of workers to be done with should be the total. Is it the same? It's the same. Yes. Yeah. It should be the same. So the next one here, so now you are supposed to say Ni kama tulifanya ama tuachie hapo. What do you think? Next here now, multiplied by the transition matrix should give you next 2 years. Next year but 1. Next year but 1. Because the question is asking us for the next 2 years. Eh? So then it will be a case of 75, 93, 137.5, 194.5. You multiply by 0.95, 0.20, 0 and 0. 0, 0.7, 0.2 and 0, 0, 0, 0.65, 0.20, 0.05, 0.10, 0.15 and 0.80. Now our time is almost over and there are still several questions. We were officially supposed to end today. Become that I will go up to 2. You'll be getting energy. So just be talking to myself. Eh? Ugly. Will you get anything? Or enjoy chat, broke, chat. Okay, give me the answers. We can try and try to see the progress we can make. La kwanza 89.85 2.6 128 points 28. The last one. Yes. 189.28. Good. That is about Markov. In case you find it, you should be comfortable with it. Question 7. The following regression equation was calculated for a class of 24 CPA 2 students. So we have that equation and we are told to get the T ratio. T ratio, how do you get T ratio? T ratio is what we are calling T calculated. It is given as B out of SB. That's how you get the T ratio. So divide by the. So for x1, it is 0.021 divided by 0.019. We need to 3 decimals. 11.053. Then x2 is 0.075 divided by 0.034. 2.206. X3 is 0.043 divided by 0.018. 2.389. We okay? So the confidence interval, for you to get the confidence interval, you must get the critical value. So plus or minus t at 1 minus 0.05 out of 2
First one
is 1.
1.1.
That way, 0.53. Okay. So I'm saying now to get the critical, plus or minus t1 minus this n minus k. So n is 24. Minus k. So k is the computed values. And I told you unahesabu the intercept and the slopes. So the slopes are 3 of them. Kuna hizi tatu na intercept. So k is 4. N minus k. Or if you want, you can still work with 1 because it is the slope. Let's work with 1 because they are slopes instead of the whole equation. Come on, the whole equation be okay. So let's work with 1. So nataka uende kwa tables unisomee. Ulisema unaenda kwa mahali kumeandikwa true confidence. Unarudi nyuma kwa 95%. Unaruka kwa 23. 23. 2.0687. So the confidence interval is normally given as B plus or minus T 1 minus alpha out of 2 N minus 1 SB. That's the formula that we use. So for X1, it is 0.021 plus or minus 2.0687 times the SB, which is 0.019. You have to catch it for yeah, just so. Or if you are quick enough, give me the final result. 0.021 minus 2.0687 times 0.01. Negative 0.018. 3 decimals, eh? Okay. And on the upper side, 0.003. We go to X2. X2 is 0.075 plus or minus 2.0687 times the standard error is 0.034. So give me the lower limit. Zero point zero zero 0.0046. 0.1403. X3 is 0.043 plus or minus 2.0687 times 0.018. Zero point zero zero 0.0057.
Zero point 0802.
0.0802. What assumptions did you make in A above? Those ones we know they are called what? The assumptions of the regression. I gave you 6 assumptions. So those are the ones that we're supposed to talk about there. The assumptions of regression, linearity, and whatever else. Then, which regressor gives the strongest evidence? So for you to give the evidence, you have to compute you have to check whether it is significant. So in inaangaliwa namna hii. You have the regressor, you have T calculated, then you have plus or minus T critical, and then the conclusion or the comment. So X1, X2, and X3. We already have computed the criticals, the calculated, they are here. The criticals are plus or minus 2.0687, plus or minus 2.0687, plus or minus 2.0687. Sasa, if you remember what we said, when we were doing this test, tukuanga na kitu inakaa namna hii. Hii ndio ilikuanga negative na hii ni positive. If you are here, we will say reject. And the other word for reject is significant. If you are in between here, we will say accept. And the other word for accept is insignificant. Na hapa ni significant. So sasa utakuwa unaangalia hizi. This is minus 2.06 and this is positive 2.06. Sasa unaangalia hii where it is. So hii iko side gani? Siko hapa ndani. So that means it is what? This is the t-test. It's the t-test that we did. Hii where is it? It is significant. And this other one, it is what? It's also significant. So sasa ukiulizwa who is the strongest, eh? The strongest ni mwenye ameenda far from the border. Mwenye ameenda bali from the threshold. So, si ndio iko na the highest. So this is the strongest.